Welcome back to our YouTube channel. Thank you for coming back to learn with us. Thank you. Today we want to look at sufficient estimator. All above our videos we have looked at three properties of estimators. We said unbiasedness, we said consistency, we said consistency, and we also said efficiency. So today we want to look at what we mean by a sufficient estimator. Welcome back, and if you are new here, subscribe to our channel, comment, like, and share the knowledge you have received. Thank you very much. So what do we mean by a sufficient estimator? First of all, the idea of sufficiency in statistics came from a person called Fisher, a great statistician, who came up with an idea of sufficiency in statistics. Therefore, what did Fisher say? He said, let x1, x2 to xn be a sample from a distribution whose density function is f of x theta, where theta is an unknown parameter. A statistics t1 is equal to tx1, x2 all the way to xn. It's a sufficient statistics for theta if and only if, for every statistics t2, t3 all the way to tn, the conditional distribution of t2, t3 all the way to tn given t1 doesn't depend on the parameter theta, however, be the fixed value of t. So we are being told a statistic is maybe like an estimator. T1 is equal to t of x1, x2 all the way to xn is called a sufficient statistics for theta if and only if every statistics t2, t3 all the way to tn, the conditional distribution of t2, t3 all the way to tn given t1 doesn't depend on the parameter theta, whatever be the fixed value of t1. So we're going to look at an example which is here of before an example. We'll look at for an example. Let the distribution of x be x and probability of x 0 and 1. This is a Bernoulli distribution. 0, 1. Then the probability of 0 is 1 minus theta, and probability of 1 is theta. Probability of x, the density function is given by theta power x, 1 minus theta power n minus x. Or x is equal to 0 and x is equal to 0, 1, where theta lies between 0 and 1. That means theta is a fraction. Check whether there's a statistics t, which is a summation of xi from I is equal to 1 to n, is a sufficient statistics. Check whether t, which is summation of I from 1 to n of xi, is sufficient statistics. So here we have a statistics by the name t, which is summation of I from 1 to n xi. So we want to prove that is t a sufficient statistics of theta parameter, which is here for Bernoulli distribution, with the following probability density function. Solution: f of x1, x2 all the way to xn, given t is equal to t, given t1 should not depend on theta, as we discussed what a sufficient statistics is. So f of x1, x2 all the way to xn, given t is equal to t, given t is equal to t, given t1 should not depend on theta. Conditional distribution f of x1 all the way to xn, given t is equal to t. So we have probability of x1 all the way to xn divided by probability of t is equal to t. So we have probability of x1 times probability of x2 times the probability of all the way to times probability of xn divided by probability of t is equal to t. So theta power t bracket 1 minus theta n minus t over n combination t theta power t bracket 1 minus theta n power minus t is equal to 1 over n combination t. So f of x1, x2, all the way to xn, given t is equal to t, is equal to 1 over n combination t. N combination t.